sigma, type the statement. Okay, we want to follow the books. Output. Okay, now output you can look using scope. Okay, very easy lah. And then run. Okay, until the sound ting. Double click. Where is it? So here. So this is the output. Okay, so compare the output from our notes, additional notes. Same notes, not the same note. 100%. Okay, almost the same. Okay, from our notes in our books here. Okay, put some here. See, we can see the we can compare lah. This yellow line, our simulation is at 4 kilonewton. So 4 kilonewton is the green line in your books. Okay, so the shape here is for 4 kilonewton. The green line, this one. Okay, almost the same lah. Okay, so the simulation successful. Okay, but if you see that our graph, the simulation graph is not so nice, change the input. Not change the input. Change the time. Constant sample time change to 0.02. Usually I use 0.02. You can use 0.01, no problem. Okay, so and then when you run the graph will look nicer lah, smooth graph. That you can compare again. I'm sorry, not this one. Compare to our book inside. This is for 4 kilonewton. So what if you want to test for other load, such as you have 2 kilonewton, 4, 6, 8. Very easy. Just copy paste. Copy paste is easy, right? Copy and paste. Copy and paste. Okay. So another 2. So put here. Okay, and then put here. So you have I reduce the size lah. Sometimes the size is too big. Don't worry, reduce the size. Okay, same model, same subsystem model. Okay. Input you start with 2 kilonewton here, and then you have input 4 kilonewton, and then next you have input 6 kilonewton, and then you have input 8 kilonewton, based on our books lah. Okay, sigma, same sigma. So just connect the sigma here lah. Sigma from negative 100% to 100%. Okay, save. And then how to check so many output? Use marks. Mana marks? Mark is in common. Commonly use blocks. Use marks. Change to 4 inputs. Alright. Okay. So connect everything, all the output in the marks. Fx. Save. And then run. Okay, see the output. Nice color. Where is it? So you can compare. See the green line from this simulation. The green line here is the force for it 8 Newton, kilonewton, load 8 kilonewton. So this is the Fz, Fz. You have to analyze the graph. You have to explain the graph. Okay, at the slip ratio 20%, you can pick 40, you can pick 60, no problem. As long as there are some significant difference between the lines, among the lines. So this is sigma. Sigma 20%, so you look at this line. Look at this line. You look at this line, you can see that when Fz is increased, okay, this line, this location, Fz increase, Fz from 2, 4, 6, 8. So from blue to green to red to apa? What is this color? Color young blue. Biru muda yang blue, light blue, okay, so you can see that the Fz, no, we want to find Fx, increase Fz, what happened to Fx at 20% sigma or longitudinal slip. So when we increase Fz, we also increase the longitudinal force. Negative 20 degrees and negative 20%. If the slip angle, or not slip angle, sorry. If the sigma or longitudinal slip is negative 20, at specific line here, if we increase the value Fz, Fz increase, what happened to Fx? Okay, you can answer very easy. Increase the Fz. So from 2 increase to 4, increase to 6, increase to 8. So what happened to Fx? Is it increase or is it decrease? Actually, what happened to Fx, the magnitude, or we can call it magnitude or absolute value of x. Fx is increased, but the direction of Fx is different direction. Okay. Fx is the longitudinal force of the tire. So this is tire. Okay, I change color lah. So positive Fx, I cannot change. Sorry. Change to red. Positive Fx is this direction lah. This is Fx positive direction. Okay. Negative Fx means different direction. This direction. Okay, so this is negative F X. So tire rolling like this. Okay, so the longitudinal force of the tire positive to the front, negative to the rear. So the effect to the what do you call? If you increase the Fz, you will increase the Fx at different direction. I think that's all for today lah. You can continue to model the model for Fy and Mz at your own time. Okay.